Hello, in this video I'm going to walk through question 7.2.11-T from the 7.2 MyLab homework. It reads, a clinical trial was conducted to test the effectiveness of a drug for treating insomnia in older subjects. Before treatment, 14 subjects had a mean wake time of 101.0 minutes. After treatment, the 14 subjects had a mean wake time of 80.8 minutes and a standard deviation of 21.1 minutes. Assume that the 14 sample values appear to be random from a normally distributed population and construct a 95% confidence interval estimate of the mean wake time for a population with drug treatments. What does the result suggest about the mean wake time of 101 minutes before the treatment? Does the drug appear to be effective? So this is going to be a three-part question, and the first part of the question is actually to construct the confidence interval. The second is to compare the before number, or 101 minutes, to the confidence interval. And then the third is having us analyze our answer. So what might have thrown you off or been a little bit tricky about this question is they give you two mean values. So the first value that we're given for a mean is 101 minutes. But this value is what we're going to be comparing at the end. Once a treatment is applied, the mean of the 14 subjects, the mean wake time is 80.8 minutes. This is the mean that we're going to use in our calculations, and the standard deviation is 21.1 minutes. And we're looking to construct a 95% confidence interval. So I always like to write down the information that I know. The sample mean, X bar, is 80.8. The sample standard deviation, S, is 21.1. We're looking to find a 95% confidence interval. Since we're finding the confidence interval for a mean here, we can either do a Z interval or a T interval. We do a Z interval when the population standard deviation, sigma, is known. We do a T interval when the population standard deviation, sigma, is not known. In this problem, we happen to have S is 21.1. That is a sample standard deviation. So we can say here that we do not know the population standard deviation. So sigma is unknown. And I usually like to go ahead and write that right on my paper so I choose the correct test. Or I'm going to find a T interval. So let's pull out our calculators and do that. To find a confidence interval when sigma is unknown, in your calculator, you can press stat and then scroll over to tests, and you're going to do a T interval test, which is number 8. You can either scroll down to 8 or you can press the number 8. We're choosing data or stats. I didn't put any data in my list, so I'm going to just use stats, which is the kind of the summary statistics that were given in the problem. If you'd been given a data list, you would type it into one of your lists and choose data here. But that's not what we were given. So X bar in our problem is 80.8. So type in 80.8 for X bar. The sample standard deviation is 21.1. The number of data items, N, is 14. Our confidence level is 95 because we're trying to do a 95% confidence interval. So we'll put 0.95. Remember, you can only use decimals, not percentages in calculations. And now go ahead and calculate. We're given 68.617 to 92.983. The question asks us to round each of those to one decimal place. So let's go ahead and write our confidence interval. Our rounded answer for the 95% confidence interval estimate of the mean wake time for a population treatment is 68.6 minutes to 93.0 minutes. Next, we are asked to analyze our result. What does the result suggest about the mean wait time of 101 minutes before the treatment? Does the drug appear to be effective? and you have a fill in the blank to fill out. The confidence interval, it does include or does not include the mean wake time of 101 minutes before the treatment. Well, I've written our confidence interval of 68.6 minutes to 93 minutes below. Is 101 included in that? No, 101 is higher. So we're going to say here, the confidence interval does not include the mean wake time of 101 minutes before treatment. So the means before and after the treatment we can choose are different or could be the same. They're different. This result suggests that the drug treatment does have an effect or does not have an effect. I'm going to say that it does have an effect. And there is your answer. I hope you found this helpful. Please feel free to reach out with any other questions that you might have.